Hi, everybody. Welcome to Math with Ace. Today we are doing statistics. We're going to be talking about percentiles, quartiles, and outliers. Percentiles, you're probably most familiar with if you have had a child or if you have taken the SAT or the ACT. When you are looking at percentiles, you're talking about the number of people that you are essentially better than or more than. For example, in the ACT or the SAT, let's say you scored in the 75th percentile. That means you scored better than 75% of the group. So there's 75% of the scores are underneath that percentile. Same thing with babies. If you're in the 10th percentile for weight, that means that you're smaller and you weigh more than only 10% of babies that are born. Quartiles are going to be something that cut our data into quarters, and outliers are going to be data that are unusual in comparison to our overall distribution. So when we're talking about quartiles and outliers, the first thing that we want to do is put our data in order. Same thing when you're calculating the 5-number summary or the median. It's important to have your data ordered so that you can look at your group as a whole to calculate your percentiles and your quartiles. So when I put my data in order, I am going to make marks to cross off because this is actually probably the most challenging part, is making sure you don't mess up the numbers that you have. So I'm going to put these in order and then we'll come back together. Okay, so here we have our data in order. And these are numbers that represent the number of siblings an individual has. In this data set, there are 20 observations. And so if I wanted to determine the quartiles, what I need to do is I need to figure out where my median is, and then I need to figure out the median of the lower half and the median of the upper half. So I'm splitting my data into essentially 4 separate groups. And when there's an even number of data points versus an odd number of data points, how you are finding the median, it is actually a little bit different. If you have an odd number of data points, you're going to find that there is a middle number. If you have an even number, you're going to find that there is not an exact middle number in the observation. And you'll need to find the average of the middle too. So for instance, if I'm trying to find the middle of 20, there's going to be 10 on one side, 10 on the other, and the median is going to fall in the middle. And when I'm calculating the median, what I do is I cross off each number on either side until I get to the middle. You can also use n plus 1 divided by 2 to find the location of the median, not the value. So if there's 20 data points, I add 1 and I get 21. I divide that by 2 and I'm going to get 10.5. That means that the median lives between the 10th and the 11th observation. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The median is going to be right in between 2 and 2. So the way that I find the value of the median is I take those two numbers, observation 10 and 11, I add them together and find their average. 2 plus 2 is 4, divided by 2 is 2. So the median for this data set is 2. The lower quartile, or quartile 1, is going to be the median of the lower half, and the upper quartile is going to be the median of the upper half. So in this data set, in the lower half, I have 10 values. So again, if I do n plus 1, that's 10 plus 1 divided by 2. That's going to give me the location of the median. 11 divided by 2 is 5.5, which means the median is going to be located between number 5 and 6. So 1, 2, 3, 4, 5, the median of the lower half is going to be located between those two numbers. So this is going to be your first quartile. I need to take the average of 1 plus 1 and divide that by 2. So 2 divided by 2 is 1. So what we're doing here, finding the average, now obviously you could see the average of 2 and 2 is 2. The average of 1 and 1 is 1. So I should just be able to know, oh, okay, it's 1, it's 2. But if the numbers were not the same, what would you do? You would need to add the two numbers and divide them by 2 because you're finding the average. You're finding the middle between those 2 points. Let's do the same thing for the upper quartile. I have 10 points in the upper half. So again, 10 plus 1 divided by 2 is going to give me the location of the median. $11 divided by 2 is 5.5. So I can't go from the very beginning to count in between 5 and 6. I need to be counting in between the upper 10. So 1, 2, 3, 4, 5. In between the upper 5 and 6 would be 3 and 3. What's the middle of 3 and 3? It's 3. But how is that true? By taking 3 plus 3 divided by 2. So 6 divided by 2 is 3. So the first quartile is 1, the median is 2, and the upper quartile is 3. So now I have 4 sets of data. The numbers that are below the orange line, the numbers that are between the orange and the purple, the number between purple and green, and the number above the green. So that's cutting our data into 25% each. So 25% live below the first quartile, 25% live between the first quartile and the median, 25% fall between the median and the third quartile, and 25% fall above the third quartile and the maximum. And so now you have your data cut into quarters. I could also calculate percentiles and figure out what number of data points fall below, let's say, 5. So 5 is here. How many data points fall below 5? That's 18, because 5 is the 19th observation. So 18 out of 20 fall below 5. That's going to be 90%. So 5 is the 90th percentile. I can do that with any of my groups to figure out what the percentile is by determining how many values fall below. So how many values fall below 5? There were 18. 18 out of 20 was 90%. What about outliers? Outliers are calculated by taking 1.5 of the interquartile range. The interquartile range, which is abbreviated IQR, is found by taking the range of the quartiles. The range is just the high minus low, so the upper quartile minus the lower quartile is your interquartile range. So to find your outliers, you multiply that by 1.5. And then you need to add that to the upper quartile and subtract it from the lower quartile. If we look at a box plot, what you're doing is you're creating fences based on how wide your middle 50% are. And your fences are located outside of that 50%. So you're going further to the right and further to the left of your box plot to create these fences. And the fence width is based on how big the interquartile range is. So you're multiplying this box by 1.5. So you're getting a length of 1.5 the box plot, or 1.5 the box in that 50%, and you're adding it to the third quartile and you're subtracting it from the first quartile. Because in a box plot, the upper quartile is the right-hand side of the box, the lower quartile is the left-hand side of the box. And so you're adding that distance to the right, to the left to create these fences to determine if there are outliers. So you have these formulas of the third quartile plus 1.5 the interquartile range, and the first quartile minus 1.5 the interquartile range. But essentially what you're doing is you're going above the box and below the box to create boundaries, and anything outside that boundary is considered an outlier. It's unusual because 50% of the data live within that box, and then you have 25% to the left and to the right. So anything that's outside is considered unusual based on how large the box is. If the box is pretty skinny, it means that things are grouped together. If the box is very large, it means that they're not as grouped together and there's more variability. So our interquartile range was Q3 minus Q1, or 3 minus 1, which is 2. So the IQR was 2. I'm going to multiply that by 1.5. So 1.5 times the IQR is 1.5 times 2. which is 3. And then I'm going to take that 3 and I'm going to add that to the upper quartile. And I'm going to subtract that from the lower quartile. So remember, 1 is addition and 1 is subtraction. You go above the upper and below the lower. So Q3 was 3. That's 6. Q1 was 1. That's -2. You can't have -2 siblings, so there's definitely not going to be any lower outliers. But 6 is actually the boundary, and we do have one that is the boundary. We need to go above that. So 6 is not an outlier, but anything that would be above 6 would be an outlier. So what if I added another data point to that? First, I would need to recalculate my numbers, but anything that was above that would be an outlier. Let's do one more data set. I'm going to put some numbers up here. We're going to come back, put them in order, and calculate for outliers again. Okay. So now we have another example of number of children in the family, but in this situation, we have a little bit less numbers. So we have 11 numbers in the data set here. And if you notice, we have smaller numbers, but then we have a larger observation where somebody had 10 siblings. In order to find the quartiles, we need to start with the median. So we're going to calculate the lower quartile, the median, and the upper quartile. And then we're going to calculate our interquartile range and determine if there's any outliers. So if there's 11 numbers, the median is going to be located at 11 plus 1 divided by 2. So that's 12. 12 divided by 2 is 6, which means because it's an actual number, it's the actual observation 6. 1, 2, 3, 4, 5, 6. That means that 2 is our median. And then when we are calculating our upper and our lower quartiles, we do not include the median in our observation. We did not include our median in the upper and lower half previously, but notice it wasn't an actual observation in the data set. When it's an actual observation in the data set, we do not include it either. So when we're looking at the lower half, we are looking at the numbers to the left of the median and to the right of the median. So if I scroll up really quickly, we did not include the median in our lower half or our upper half because the median was located between those 2 points. So don't include your median when you're calculating your quartiles. So now I have 5 numbers in my lower half. So if I take 5 plus 1 divided by 2, that's 6 divided by 2 is 3. That means that the lower quartile is the third observation. 1, 2, 3. That means that 1 is the lower quartile. And then the same thing will be true of the upper quartile. It will be the third number in the upper half. So 1, 2, 3. 4 is going to be the upper quartile. So when I want to find the interquartile range, I'm subtracting the upper quartile minus the lower quartile. 4 minus 1 is 3. I'm going to multiply that by 1.5. The 1.5 of 3 is 4.5. So the interquartile range is 4.5. Then I'm going to add that to the upper quartile. So Q3 is 4. 4 plus 4.5 is 8.5. I'm going to subtract that from the lower quartile. The lower quartile is 1. 1 minus 4.5 is -3.5. I can't have -3.5 siblings, so that's not going to be any lower outliers. But I do have a data observation that's above 8.5. It's the number 10. So 10 is an outlier. And if I was to graph this box plot, there's a difference between a skeletal box plot and a modified box plot. A modified box plot shows outliers and then makes the upper whisker end at the next highest value. A skeletal box plot just does whiskers and does not indicate outliers. So a skeletal box plot would have the minimum of 0. Make my numbers go. the first quartile of 1, the median of 2, the upper quartile of 4, and the maximum of 10. We would draw a box around the quartiles. We draw a line down the median and connect our whiskers. If you're doing a modified box plot, you still have those same points. However, 10 is an outlier. And so instead of connecting to 10, I'm going to go to the next highest observation, which was 5. And so if you look at, let's say, Staplet or one of your other pictures and you're doing a modified box plot, one of your other programs that can graph for you, you will notice that the box plot is much smaller together and has the whisker does not connect all the way to the outlier. And you'll see that without that outlier, it's pretty consistent. That one observation does skew things much to the right. Hopefully this was helpful. Thanks for watching. Continue our series on statistics. We'll be talking about the 5-number summary and how to calculate in our next series.